This conference will now be recorded.
Good morning, friends. Welcome to GoOnlineTrainings.com. So, we are discussing about derived tables yesterday, right? Using derived tables, you can write beautiful queries, right? What is a subquery we discussed? What is the derived table we discussed? What is a subquery? Subquery is a query in the where clause or in the select clause or in the having clause is called as a subquery. A query in the from clause is called as a derived table, right? So I had given couple of examples in yesterday's class, and so this interview question we cracked it, right? So this was the data and find out the month-wise number of new customers. I think we cracked this. And one more question asked the other day: find employees with salary higher than their department average. Clear? So here, John is working for 10,000 salary per month, and HR is the John's department. Girish salary is this much and is into sales department. Manat, is into sales department. Salman $14,000 and HR department. Ratan 9,000 HR. Peter 11,000 sales. So the question is very simple question. Find the employee with the salary higher than their department salary. For example, John belongs to HR and Salman belongs to HR, Ratan belongs to HR. Now you need to find out what is the department wise average salary. Two departments are available. One is sales, the second one is HR. So I wanted to find out grouping by department and average salary. That is the first query. Then, but I don't need the department wise salary, right? So what I do, let me quickly create this table, right? So this is the table I'm creating. Create employee ID, employee name, salary, department name. So I wanted to insert the same data, John, Girish, Manath, and this is the data I have inserted, right? So what I need first, I need what? I need uh, department wise average salary. First I need to find out, then what is that? Find the employee with salary higher than their department average. First find out what is their average salary. To find out the average salary department wise, so what we can do, we will go select department wise, right? So department wise average salary, average underscore sorry, average salary as average salary, clear, from the table name. Table name is called employee info. Will this work? It is not going to work. Why it is not going to work? Because apart from aggregate function, because this is aggregate function, so apart from aggregate function, whatever you have, that has to be there in the group by clause. So this is the error message we get it, right? So this is what we discussed already. So you will not be able to get the data. You must be writing department name in this. Am I clear? So now you will be able to find out the department wise average salary. Okay. Now you can just copy with headers, open some Excel sheet and just put it there. Okay. So department name and this is the average salary of that employee. Clear? So I wanted to remove this zeros. Okay. So HR department average salary 11,000 and sales department average salary 10,333. Clear? So what is the question? The question is very, very simple. Find the employee with the salary higher than their department average. Clear? So their department, HR department average salary is how much? 11,000. 11,000 So we need to get higher than the 11,000. So for that, what I'm trying to do, I'm trying to write. So this query I'm going to be using, I'm going to be writing select star from same table. I'm going to be using as E1 join. I'm going to be using this as one more, table as you can give any name. Okay, E2. Clear? On condition. What is the condition? You need to match this department to this department. Okay, so that is what we need to match. So on E1 dot department name is equivalent to E2 dot department name. Clear? So this is the condition. So the data, whatever be the data that you're getting, this data plus this data. So whatever be the data that you're having, this data will get matched. Clear? So this is the data and this is the data is going to be getting joined based on this value. Clear? Based on this value. So HR, wherever HR is there, so HR and getting mapped. So it will go and it will get mapped here. Okay, let me take this. It is a joining, right? So wherever there is HR and HR, it is going to go there. And let me take HR. Okay, here and here. And the sales. So wherever there is a sales, so sales. Clear? So now this table and this table I'm joining. When I join, this is the first table and on the basis of department name, I'm joining it. HR and HR is getting mapped. Now I need to find out, is this salary is greater than the average salary? His salary is 10,000, average salary is 11,000. So this row will not come. So let me remove this row. And his salary is 10,000, but his salary is this much. Will it come? Yes, it is going to come. What about his salary is this, but it is not going to come. Why? Because it is not greater than. Average salary is this much, but his salary is 11,000. This row is not going to come. Okay. His salary is 11,000 and average salary 14,000. It is higher than the 11,000. This row is going to come and his salary 11 average salary 11,000, salary is this, so higher salaries we need, so this row also will not come. And this is the salary and this is the average salary, so salary is more than this, so we need that data. So the final answer would be 246. Clear? So that is the answer. So I need to write one more condition. So you will get all the department like this, but I need to write a condition. To write a condition where I'm saying, so E1 dot, or you can say salary, there is a salary, right? So when you execute this, there is salary, right? So there is a salary is greater than this salary. So this is the condition. So when I execute it, I should be able to get, so 462. Okay, 462. Have you seen this? We got 4 and 6 and a 2. So these are the entries we got it. So this is the complete query. So in this case also, I'm using a derived table, right? So derived table is means what? Derived table means a query in the from clause. Clear? So this is going to be executed. It is going to be getting the data. Okay, so this is going to be there. And what I'm doing, I'm taking this result set and joining with results set. So it is a simple inner join. So when I join, I'm going to be getting this complete data. So this table is going to be joining with this table based on the department name to department name. So that's what I have written. E1 dot department name equals to E2 dot department name, because whenever you join, you must have a common column. What is the common column? So in this common column is department. So in this common column is department. Clear? So based on the department name, I have joined. So after joining, I will be able to get this data. But what I need salary is greater than average salary. That condition I'm writing in the where clause. So this is what you guys need to understand. So in many interviews, they, the people are going to be asking, okay, they'll give you a table like this. They'll give you a table like this. Find out the employees with salary higher than their department average salary. Clear? First, you need to find out, department name wise average salary. That will be a derived table. Then again, you need to join this table with the original table called employee info. So that is how you should be able to do this. Clear? So then you write a condition salary is greater than average salary. So that's what. Clear? So these are the few beautiful interview questions asked in recent interviews. Please make sure that you're going to, practice these queries without fail. Now today we write some more beautiful, cube operations. Okay, almost we are going to complete queries topic today. Okay, so queries got over. You need to practice the case studies which I gave without fail. Otherwise, there is no point to continue in this batch. Clear? Now, there is a cube operator that I wanted to discuss today. In MSBI, there is a application called SSIS and SSAS and SSRS. I told you many times, right? SQL Server has RDBMS plus MSBI also. So, what is SSAS? SQL Server Analysis Services. So, if you watch my MSBA demo, recently I have conducted a demo, I think morning 8 o'clock, right? It's Friday. Last Friday I have conducted a demo, I think. So, I was talking about SSAS is going to create a cube. What is a cube? If you wanted to understand, let us understand now cube operator inside SQL. So the same cube operator is going to be working in SSAS. So there is no change in SSAS analysis services cube and the cube which is available here. Clear? So here we are using the cube as part of our queries, and there in SSAS we are going to be creating a cube, and in the by taking the completed data and to perform multi-dimensional analysis. But what is the cube all about? Let us understand today. So we know that SSAS is going to be used to perform data analytics, data analysis. That's what we discussed, right? MSBA or any business intelligence applications are used. Business intelligence, data analytics, both of them are synonyms. Are you getting? So there is no, change. Data analytics, business analytics, data engineering, and business intelligence. All these are synonyms only. You must analyze the data. Clear? So if you have the data, that is not sufficient. You must analyze the data. For example, you are getting today $5,000 or 5,000 rupees as your salary, and next year you are getting 6,000 rupees is your salary. So will you compare? Will you analyze your salary, right? So last year my salary was 5,000 rupees or dollars. This year I'm getting $6,000. You compare your salary with your friend's salary. My friend was getting last year $3,000, but this year is getting $8,000. So what you do? So by comparing these two salaries, what is that you understand? You understand that you were working for a stupid company. You need to immediately, change the company. So that is what is called data analytics. Data analytics means you compare your data with somebody else's data. Clear? For example, you take your income, you compare with your brother's income, mother, or your friend's income, or you compare your marks with the previous semester marks. So comparison has to happen against somebody or against the time frame. Last semester you got 60% of the marks, and this semester you got 78% of the marks. You're going to compare semester 1 to semester 2. So there is a growth. There's no problem. So this is what is called data analytics. Data analytics means you take the data and do the comparison. Comparison between your marks, comparison between your friend's marks, comparison between somebody else. Clear? For example, I wanted to know what is the sales in India and in America. So that is Amazon wanted to continue. Or what is the sales in New York versus Chicago? Or what is the sales in 2010 and 2011? So time wise, data analytics, or you can say location wise data analytics, or brand wise data analytics. Sony TV versus Samsung TV. Clear? Apple iPhone versus, and we have Google phone. So like that comparison has to happen. So the comparison is called as a analytics. Very in simple things, you must analyze the data. Then only you will come to know whether you are growing or not. If there is no comparison, you don't grow, right? If you don't grow, you lose the business. You need to close the business. So data analytics means comparison between what? Between your data with the previous year's sales data, or whatever you wanted to have it. So that is what is called data analytics. Clear? So or it is also called as a business intelligence. So now let us understand, a company is having a lot of chairs. These guys are selling these many chairs. Black colors, chairs, they sold 10 quantity. Chair red color, they sold 15 quantity. Table black color, they sold 20. And chair black color, they sold 20, 30 quantity. Table red, they sold 30. Right? So this is the table I have created. Now I wanted to do some data analytics. Okay, before doing data analytics, let me tell you at least. So this is my data. Okay, this is my data. I wanted to know what is the total sales happened. Total sales means I wanted to know this one, 10 plus 15 plus 20 plus 30 plus 30. So I wanted to say sum of quantity as a total. This is the query you must write. So we know how to write this query. So I wanted to know what is the total quantity QNTY. So the column name is QNTY. So I wanted to know, so this is the total. Excellent. You are able to write your one query as a developer because you know how to write a query. Now I wanted to know what is the total quantity for chairs, only chairs. So what I do, I know how to write. So I write one more query. So total quantity for chairs. This is the question. So I wanted to compare what is the sales for this, where the item name, right? If you see what is the column name in this, column name is called item name. Item name equals to chair. So this is the query. I should write it. So now what is the total sales? 85 total sales happened only for the chairs. But people also ask what is the total quantity sold for a table, right? So definitely you have to write one more query. The one more query, so here I wanted to use a table. So instead of a chair, I'll go in for a table here. So this is one more query you should write. So this is not very complex queries, but based on the requirement you are writing. Then total quantity for so black color items and red color items. So the next question people would ask you, okay, chair table we know, but what is the total quantity sold pure black, pure red? Clear? Because black means 10, 20, 30. So 10 plus 20, 30 and 30, 60. Red means 15 and 30. So like that, I wanted to create one more. This one, color is equivalent to, okay, color is equivalent to black, okay, is equivalent to black. So I wanted to have like this. So this will give me total 110 items are available. I wanted to write one more query and I wanted to say color is equivalent to red. So I need to write one more query because I know how to write the queries. I am technically very sound person. I am able to write like this. So now they would like to compare. They would like to compare black and red. They would like to compare. So black is, heavily selling, red is not heavily selling. So this is the comparison. Immediately they do it again. They wanted to compare, table versus chair. So which are the things which are selling highly? So I think the table chairs are, less and the tables are more, because 85, quantity chairs are sold and 95 tables are sold. When you do the comparison, you will come to know tables are in very good. So this is how the business is going to be comparing. So this is what I need to write these two queries and start comparing. So which color items are selling more? So total 11070. So definitely nobody is buying a red color items. So what is that I should know? I need to start inventory more and more black color items only. I should, put in stock in inventory, because more demand is there. So when you do the data analytics, lot of things you need to perform, because more people, buying black color items. So definitely I need to have more inventory. So nobody is buying a red color. So what should I do? I need to reduce the cost for the red color chair or red color table. So all this, decision making has to happen, so that the business also for red color will increase. Are you getting the point? So why are we doing this kind of a summing and everything? Because you wanted to compare the data. You wanted to analyze the data. You means not you. You're a technical person, not you. These numbers will be given to the business managers. So there is a manager in the company who's going to be taking care of the business, right? He's called as a regional level manager, or CEO, CFO, board directors. All these people are called as a managers. They don't know anything, any technology. They know those guys are MBA guys, Master of Business Administration guys, will be part of your business. Those people are taking care of your business, right? Those people will ask you, hey Bhaskar, give me a report. So you write this kind of a query as a technical guy, you are going to give these reports to whom? To the business people. So they will analyze it. Now they will also ask you, hey Bhaskar, tell me, color wise, they'll ask me, item wise and color wise, totals, quantity. So when I say wise and wise, we know we need to use group by clause. So what is the thing I must use? Color wise means item name wise, and color wise sum of quantity. And when you say this is an aggregate function, when you use aggregate function, these things have to be there in the group by clause. Correct? So these are the things we discussed already. So I wanted to know item wise, color wise, what is that sold? Now this is one more query, you write it. So now you are saying chair black 35. Now see the combinations. So how many combinations you will get? Let me remove this. Okay. Now you're getting chair black color 35, table black color 75 you sold, and chair red 50 and a table red 20. So You see, when the combination is this, which are definitely selling more, you could see black color items and selling more. Clear? Always. Clear? So that is what you can answer, you can see, you can understand. But if you see chairs and black are 35, chairs and red in 50, that means what? If you compare chairs and this one, chairs and red are selling very very good. That means what? You order more, more red chairs rather than black chairs. So that means in your inventory, you need to keep more red color. Clear? Color wise you have in this one, but if you particularly see item wise, so table red only 20, table black 75. That means what? You know that people are buying more chairs in red and less chairs in black. So that is what you need to understand. So this is item wise, color wise combinations. Clear? So you're going to write a lot of queries like this. So how many queries you have written? You have written one, two, three, four, five, six. So lot of queries you're writing. So what Microsoft is saying, if you write only these many, you're writing only for this data, you're writing this much queries. But if you have a black, red, blue, yellow, green, apple, red, orange, if you have thousands of colors and thousands of items, then you will go mad. You put a chair, you put a table, you put a cot, you put a black, red, orange, green. So as a technical person you will go mad by writing these queries, because you have only two combinations. What are the two combinations? Item and color. Item, you have a chair and a table, and a color black and red. So only four combinations maximum. But if you have thousands of colors and thousands of items, then you see the combinations: caught in red, caught in blue, caught in yellow, caught in pink, caught in orange, caught in green, caught in blue, dark green, yellow green, blue green. Again, chair in red, chair in orange, chair in blue. So you go mad to create these many queries. That is the problem of SQL. Clear? SQL is very very good. If you wanted to write individual queries, you need to keep on writing, keep on writing, keep on writing. So one developer is not sufficient. A lot of people are going to be writing the queries. So that is when, see, if there is a more work, what we do? We put a machine, right? We put a computer there. We don't want to do the things by the human beings. Clear? So instead of a technical SQL person is writing all the queries like that, what we do, we get a computer. Inside that computer, whatever we are doing, so one application we're going to be creating, that application is going to be doing all these permutations of combinations of aggregations. Clear? So this is writing these many queries. Who's that? That person is called as a cube. Whatever you're writing, instead of you writing, you're a human being. Human beings cannot do so much of a coding, right? So can you do the so much of coding for all permutations and combinations? You'll go mad. For example, I have only two combinations. That's what I told you. Tomorrow I'll increase colors, I'll increase items, I'll increase the location also. So I need color black in India, color red in India, color yellow in India, color this one in India, again color red in Chinese, color black in Chinese, China, like that, color black in America. So you go mad to create those many combinations of the data. Clear? So that is where what we do, instead of you and me writing the queries, SSAS application is invented. So what SSAS is going to be doing, which is going to create all these aggregations. So this is aggregated data, right? This is not a single item data. All chairs black color items completed data. This is total. This is what is called aggregations. Clear? So all permutations, combinations data you will be able to get. So we are writing these many queries. Now what I do, I am going to be introducing a cube here. Okay. If I introduce cube, what is that I should do? I should say with the cube. This is without a cube. You got only four combinations. One, two, three, four. You did not get many combinations. But if I have a cube, if I say with the cube, I did not change anything. See the combinations. You see the combinations. This is the data you got it. Now you read what a beautiful thing it has done. Child black 35, child black 35, table black 75, okay, table black 75. Null means what? Null means any item, but black color item is 110. See now, any item, black color item is 110. To get this, we need to write this query. Black color items. This is the query we should write it. So without writing the extra queries, only the cube operator is giving you multiple permutations and combinations. Now see the beauty. Chair red 50, chair red 50, table red 20, and null red 70. What is the meaning? Meaning is any item, red color item 70. So this is equivalent to this query. Any item, red color item. So this is the query. Okay, 70. So this is the one. Null means what? Total items. That means what? Whether it is any item or any color, total items are 180. This is equivalent to the first query. Total items 180. Right? So this is one more aggregation. The next aggregation, chair null 85. That means what? Chair is this one, but any color item. So this query is equivalent to this query. You execute this 85. So only chairs any color. So chairs any color, that is null. 85, table any color, that is null. Now see, it is only grouping operation. It is a group by cube. So what will you understand? Cube operator will give you all permutations and combinations of aggregation. This is what is called multi-dimensional analysis. Without writing so much of a code, so these many queries we should write. Instead of writing these many queries, when you create a cube, when you write like this, you will be able to get lot of permutations and combinations of data. Aggregations are going to be there. You need not scratch your head. Should I use this? Should I use this? Should I use this? Why? Because one, cube is going to be creating all permutations and combinations. This is the beauty about the cube. The same cube we are going to be using in SSAS cube. There also, when you supply the data, all permutations and combinations of the aggregations are going to be happening automatically without writing, not even single code there. Clear? So SSAS is going to be taking the complete data. So what is the table I have taken? I have taken only one table. Tomorrow you may take in lot of tables as A join with some other table, table B, table C, table D. Then you have a lot of things here. Item name, color name, location name, then you have month wise, year wise. So lot of combinations of data, right? So you can join lot of tables here, lot of combinations here. All aggregations are going to be coming with the help of a cube. This cube, sample purpose, this is added in our SQL server, but the cube is going to be having lot of aggregations. I have very limited data in my item table, but you think if you have a 10 million data in this table, and not only this table, you're joining with some other table, and the table is called some ABC, and this is having some 10 million data. When you have 10 million data into 10 million data and see the aggregations, your query will take a minimum 3 to 4 hours, and your SQL server will be down, right? Because so much of aggregations have to happen, because definitely I cannot write the same thing in our SQL itself. So we need to remove and keep it into one more machine, one more application. That application is called as a SSAS application. Clear? SQL also can do it, but why are we separating it? Because you are going to be, segregating, because to diverse the load. For example, you wanted to make a pizza. What you do? You get vegetables, you chop them, you clean them. You're going to be making a pizza for your family. In your family, there are 2 to 3 people. You can make a pizza. But when you have thousands of people and thousands of pizza, you make it. Will you do the chopping? No. What you do, you hire one more guy only for cleaning. You hire one more guy only for chopping vegetables. You hire one more guy for only, making the the other raw material. So what, the same work will get divided. Otherwise, the single person can do anything. SQL can do anything. SQL can do also cube operator. But why are we removing this work and giving to one more application? Because tomorrow when you have a large amount of data, SQL server cannot do storing of the data in a tables and taking all the data and aggregating means the SQL server will fail in the in real time. So what we do, we give this data to one more machine. The one more machine is called as a SSAS machine, that is going to be taking all the data from the SQL Server table and creating these many aggregations. Clear? So, however, if you're working for three people, you're doing all the work, chopping the vegetables, cleaning the vegetables. But when you wanted to prepare a food for 1,000 people, you're not going to be doing all the work with a single guy. You distribute the work, right? So one guy is going to be creating something, one guy is cleaning the vegetables, chopping the vegetables, and one more guy is preparing something else. So you distribute the work. So SQL is going to store, and SSA is going to analyze, going to create this kind of an aggregations. One more guy is going to display this data. So that is called as reporting. Clear? Like that, one guy's work is getting distributed across many people. So in this also, one work. So what is the work here? The work is store the data, create an aggregation, then display the data so that I can perform data analytics. Data analytics means, again, after that I will compare this data. So which color is good and which items are good, and where the sales is more, where the sales is high. So this data will be given to the business management people. So SSAS data, cube data will be given to whom? Business, management people, decision makers. Then they will understand, okay, chair black 35, but chair red, where is chair red? Chair red is 50. They understand chairs, people are buying a more radical chairs rather than black color. So this is what is the learning point, or the business, they understand. So this is what is called, you tell me something about your data. So when I give this data, now you can tell what is the data. You can tell, now we can say black color chairs are not selling in your company. That is what insights about the data. Somebody will say, you tell me your data and I'll give you some insights, right? So insights means this is the data. So you can tell them that, chairs 85, tables 95. You can say tables are, more sold in your company rather than chairs. That is also one more, point. It is insights about your data. Clear? And you see, red color items are 70, black color items are 110. You can tell them that in your company, you are selling more black color items than the red color items. You are selling more, black color tables than, more, no, not more table black, table red. Yeah, table red, less table black is more. So table black colors, selling more, table red are very, very less. So all these things about, insights about the data. You give me your data, I can tell you how your business is happening. Clear? So this is what is called a data analytics means. Decision makers wanted to understand which brand of phones are selling more in India, which brand of phones more selling in America, last Christmas versus this Christmas, last Ramzan versus this Ramzan, last Dasara, versus this Dasara. Like that, they're going to be comparing versus brand versus color versus mobile, brand, model, iPhone, year, location. Lot of things are going to come. So here I'm talking about only item name and color. Then they'll say last Christmas versus this Christmas, and what is the sales, and last, Apple iPhone versus this year Apple iPhone sales across the world. So what is the sales? So like that, you will have a lot many combinations. Clear? So what is the beautiful thing that we can do with the cube? Cube can create multi-dimensional aggregations without writing these many queries. SQL developers are definitely a donkeys. Why? Because they need to write so much of a work. They need to create this much of a work, but a intelligent guy will create only one query. Clear? and the same thing will get implemented in your SSAS software. What SSAS software is going to be doing? SSAS software is going to come to SQL Server and it will take the data. So there is a table available in the SQL Server. SSAS will go and fetch the data. That's it. So taking the data from SQL Server and performing aggregations. Aggregations means it's going to be creating this kind of an aggregations and it will give you these totals. So that is what it's going to be doing. So storing data is going to be happened by the SQL Server, but aggregations, operations, and everything will be performed by the cube operator. So the cube which is there in SSAS. Clear? If you have a small amount of data, SQL also can do. That's what I told you. Your mother also can prepare a complete pizza if there are only 3 to 4 people in your family. But if you have thousands of people invited for a party, your mother cannot do that. Your mother is restricted to do some little work. So now your mother is SQL server. Your SQL server restricted to storing your data. It cannot do aggregations. So the aggregations part will be handled by one more guy. Chopping vegetables will be handled by one more guy. Chopping means cutting, right? So cutting, cleaning, all these things will be handled by one more guy. So when the work is more, we distribute the work. So however we are distributing the work in, as a human beings, that is how the machines also will get invented. And you do only chopping, you do only cutting, you do only cleaning, you do only this, you do only storing of the data. So that is what the each and every machine is specialized. Clear? So generalized to specialized. Clear? So now SQL Server can do with cube and everything when you have less amount of data in these tables. But when you have lose huge amount of data, that is where we're going to be switching from SQL Server will handle something, only storing of the data. Oracle will handle storing of the data. SSAS will create a lot of aggregations by taking the data from the Oracle or from the SQL Server. Now, that is what you must understand cube operator. Clear? So only one thing we are going to be writing here, but in SSAS, we are not going to write this, syntax also. Automatically, it will do everything. Clear? It will taking care of everything. So you have one more operator called roll up operator. Okay. So instead of a cube, we are going to be using a roll up. Let me tell you what is the difference between with the cube and with the roll up. Okay, the query will not change, but it will give you less permutations and combinations. Clear? It will give you less permutations and combinations. Now this is with the cube, this is with the roll up. Have you seen this? Roll up did not give you null and null. So granted total it has given you, and it did not give you this. So null black color item, that total is not available. Null red color item is not available. Clear? So chair null and this is there. So roll up will give you subset of rows. Cube will give you all permutations and combinations. Clear? So roll up will give you not all permutations of combinations of an aggregations. It will give you few aggregations. Chair. So you will get all combinations on this. Clear? So chair red, chair black, chair null, and a table black, table red, table null. So it is giving you all permutations on the item name, but it did not give you all permutations on the color. So color black, color red, color any item is not there. So color black any item is not there. So it is not going to do all aggregations on the color. So roll up operator will take the left columns and give you lot of combinations on this, and it will not give you much more combinations on the next column. Clear? It is going to be performing the operations from left to right. That means what? In the left column, it will give you, using the left column, it is going to give you all permutations and combinations. But when you go for the next column, it will not create many combinations. So you will have only few combinations when you compare with this. Clear? So that is what, if you need not every combination, then go in for this. Cube versus a roll up. Clear? So this is very, very important point. Clear? So cube we're simply understanding what is a cube operator and what is a roll-up operator. Roll-up operator will give you less permutations and combinations, but the cube operator will give you all combinations. This is what is called as multi-dimensional analysis. So all combinations. What is the grand total? It will tell you. What is the red color item? It will tell you. What is the black color item? It will tell you. It will give you all permutations and combinations of aggregations. Clear? So not normally, if you don't have this, we are not going to be analyzing the data. So always analysis is done on the number. So this is what is called analysis, right? Always analysis is not done on the character data. Analysis is done on the, the numerical data. Data analytics means you're going to be doing the analysis on the numerical data, not on the string data. So chair black, chair red will not tell you anything. Chair black sold 200. The 200 is the, performance, figure or point for us. So always analysis is going to be done on the numerical data only, not on this data. Item color, item color. On this, nobody is going to be aggregating, right? So my name is Bhaskar. I am working for a company. My salary is 10,000. Okay. And your name is John and you're working for a company. Your salary is 70,000. So people are going to be analyzing my salary versus your salary. So on the numerical field only. Clear? That is what is very, very important. So data analytics is going to be done on the numerical data, but these are supporting details. So what is the 30? 30 means chair black color 30. That is the supporting detailed data. Clear? Thank you guys. And I think so there is one more interview question. I have SQL and server. I have SSIS and SSRS. When the ID is the same, when the ID is the same, I wanted to get data like this, SQL and server, and I should get one. And it 2 and SSIS, SSRS, I should be able to get in one row. These are multiple rows and has to be grouped together, and I should be able to get into one row. So based on this number, clear? So a table name is called table tests. So this is also one more interview question asked recently. I have already taught this. Okay, this is available in there is a video posted. I don't know whether you had watched this video or not. So I strongly recommend to watch that video. So that is string aggregate. So this is the video. Okay. You watch this string aggregate video so that you should be able to perform this kind of a data. Okay. When the column ID is the same, I would like to have SQL and server like this. So if the column ID is the same, you need to put like this. So this can be done with the help of this video string aggregate. Please watch and make sure you have downloaded these videos. I will be deleting these videos probably today end of the day. Clear? So make sure that you have downloaded all the videos and this completes our queries. Clear? It completes queries. So we had completed SQL clearly. Am I clear? So that's what you got to understand. If you have any questions, you're welcome. But end of the day, guys, end of the day, you must practice the queries. Without case studies, only by watching the video, you cannot do anything in this world. Okay. So never think that by listening to the video you understand the technology. No. By practicing only you understand. Okay. Many people, you play the video for 10 minutes, you write the notes and always refer the notes. Don't play the video continuously, you'll go mad, right? Even 1 hour videos I'm creating, you cannot watch 1 hour video at a time, right? So you play for 10 minutes and write the notes. If you're getting bored, stop it, and again whenever you get again the interest, again play the remaining 10 minutes and write the notes. So writing notes is very, very important, and say video number 1 notes, video number 2 notes, like that. So tomorrow if you wanted to refer something, You know this point belong to video number 23. You play that video once again. Clear? That's what is very, very important, guys. And you can also subscribe my channel, which is there in YouTube. You can go to YouTube. So look for Bhaskar Jogich, channel. I'll be posting interesting videos there as well. You can just subscribe and you can share those videos as well to the people. Thank you, guys. Bye bye. Any other questions?